Welcome to the series, Exploring Careers in the Green Economy. This episode is entitled, A Scientist's View of Bioenergy Technology. My name is Nick Nonnenmacher, class of 2021 at Middlebury College, and I would like to introduce this episode's guest speaker. I'm joined today by Jay Fitzgerald, Middlebury class of 2006, who since January 2021 has been the Chief Scientist of the Bioenergy Technologies Office at the U.S. Department of Energy. Welcome and thank you for joining us, Jay.
Great, thanks a lot, Nick. Happy to be here.
So Jay, this series explores a number of different professional areas involved in the green economy. To start, do you think you could tell us a little bit about the mission of the Department of Energy's Bioenergy Technologies Office and how it fits within the broader green economy?
Sure. So the Bioenergy Technologies Office is one of the offices under EERE, which is Energy Efficiency and Renewable Energy. They're kind of the applied research and development arm of the Department of Energy. So we take advances that have been made in basic science and try to translate those into kind of applied R&D that can be picked up and commercialized and have an impact on on industry more broadly. The Bioenergy Technologies Office specifically focuses on the conversion of both waste carbon and also other types of biomass carbon into useful fuels and products. So the end goal really is to take some renewable inputs and be able to do things that can displace, say, petroleum for something like aviation fuel or some sort of plastic that might be in one of your bottles and make that from renewably sourced material.
Okay, cool. Thank you. How does the Bioenergies technology help to kind of shape national policy and technology outcomes?
Yeah, so the Bioenergy Technologies Office and most of DOE is not really specifically a policy development organization. A lot of the science and technology that we fund, we really are primarily a funding agency. So we fund national laboratory partners, we fund academic groups, and we fund industry groups to tackle challenges in the conversion of biomass and waste into useful products. And so the main impact that we have on things like policy are by providing the foundational both analysis and then R&D that can help to fulfill policies. There are a lot of different types of policies that sort of interact with our office. One of the primary ones are the LCFS in California, the low carbon fuel standard, and the renewable fuel standard, which is a national standard. So a lot of the technologies that we've developed have helped to fulfill the mandates in those standards to be able to use renewable fuels. Okay,
great. So you mentioned a few of the other organizations outside the government that you collaborate with. Are there any other within the government that you do a lot of work with?
Yeah, so we work a lot with partners across various agencies, and it's kind of technology dependent. We work a lot with people at EPA, at Commerce and things in terms of how we can work together to implement strategies that can have a real effect on things like the climate crisis and tackling that in terms of what are the most effective types of policies. We also work with agencies like the National Science Foundation, the DOE Office of Science, and others on specific types of technologies. So, for example, we work a lot on biomanufacturing, which means that you can take some sort of biomass-derived feedstock, and through a process like fermentation, you can turn that into a useful fuel or product. And so there's efforts going on throughout the government to tackle biomanufacturing. We try to keep those efforts coordinated so that we can really build on basic science that's been done to advance that quickly through to have real outcomes for United States competitiveness.
Okay, great. Thank you. What are some of the main challenges that the Bioenergy Technologies Office faces in kind of achieving some of its major goals?
Yeah, so we are a mission-driven agency, and our mission at the U.S. Department of Energy is really focused on providing affordable energy and also energy solutions that help to combat the climate crisis. And so by focusing on technologies that have low greenhouse gas emissions and can help to displace inputs from things like fossil fuels, we can really hopefully have an impact kind of broadly on the way that our economy functions. And so some of the barriers there are making sure that we can be supporting technologies that really do have good life cycle greenhouse gas emissions, that we are using inputs that are either sustainably grown if they're biomass-based inputs, or if they're waste-based inputs, that that waste is harvested in a reasonable manner. And those wastes can range from anything like wet wastes, which are often currently underutilized, say manure ponds or other types of wet waste that can generate methane, and we can harness that methane to make into useful fuels and products. So really coming up with the technology solutions to those types of problems are what we've charged our partners at the national labs and in industry to do. So the main barriers really are developing that technology, making sure that the technology is going to be beneficial after it's developed, and then actually helping to push it sort of out the door and get partnerships to utilize the technology that's been developed through our funding and through our awards to have an impact in industry.
Okay, great, thank you. What would you say is the future landscape of the field?
So bioenergy is at a really interesting point right now. I think there's been a broad consensus that bioenergy needs to be part of the solution if we're going to really have fulfill the Biden administration's agenda in terms of becoming a net neutral economy by 2050. And I think bioenergy has a big role to play there. There are sectors of the economy that are really that are able to be decarbonized using current technology. So things like solar, wind, hydropower, and others can help to decarbonize the electricity sector. Things like battery electric vehicles can really help to decarbonize light duty transportation. Where the Bioenergy Technologies Office really comes in the future, I think, is going to be helping to decarbonize industries that are really difficult. And so one of those is air travel. There aren't, in the foreseeable future, really good alternatives to things like liquid fuels for air because you need an energy-dense liquid fuel. And another area there are things like chemicals. Most chemicals are inherently carbon-based. All of the plastics that we utilize have, carbon-based backbone structures. And being able to, decarbonize that industry is really means finding green sources of feedstock to be able to produce those plastics, as well as hopefully produce in the future less of those plastics and be able to utilize them more efficiently. So I think the impact that biotechnology can have is really helping to decarbonize things that are hard to decarbonize otherwise in a sustainable manner.
Great, thank you so much for your perspective on that. I was wondering now if we could talk a bit more about your current role at the Bioenergies Technology Office. What's your role as a chief scientist there?
So I've been the chief scientist only now for a couple of months. My role as the chief scientist really is to help guide the overall R&D direction of the office and make sure that we're developing technologies that have some sort of scientific underpinnings that will really help them to achieve our mission. And so in that role, I kind of help to do outreach to companies, to academics, to others, to really see what the cutting edge of technology in bioenergy is, and to help us bring that into our portfolio. As part of that role, also, I'm the program manager for our analysis and sustainability team. And on that team, we help to do sort of cross-cutting analyses that look at things like life cycle greenhouse gas emissions, water quality impacts, air quality impacts of all the technologies that we're investing in. And so I help to manage a team there that helps to run these projects and make sure that the things that we're bringing to market are done so in a manner that's both responsible from an environmental point of view, but also are techno-economically viable. And so we do modeling to ensure that the technologies that we're developing are going to be able to be deployed in the marketplace.
Okay, and what aspects do you find most challenging or interesting about that role?
So I think what I find most interesting about it is that it builds on a lot of scientific expertise that I've accumulated over my career, but really, there's such a broad space that everything more or less is outside of your individual, technical expertise and field. And so one of the challenges and the things that I find most fulfilling about the job is that I get to learn a lot of new things, both about technologies, also about how analyses are performed and that kind of stuff, and really try to just help us to do the best we can to navigate that field and make sure that we're listening to the people who are truly experts in that space, and so that we can have the best R&D outcomes there.
Cool, thank you. That segues into my next question. What aspects of your Middlebury experience do you think really helped you prepare for this work?
Yeah, I think Middlebury provided a great foundation for the job that I have. And I think part of that is Middlebury has a great science program, and I learned a ton through my experience majoring in biochemistry at Middlebury. But I think it also builds on a lot of the skills that I picked up that are much more liberal arts based. I think being able to effectively communicate, being able to effectively write and to reason through things are really important skills for being able to kind of coordinate things at a level that's not, directly doing bench science, but can help to understand what the bench scientists sort of have to say and translate that into outcomes that are understandable by our sort of senior leadership so that we can, craft these kind of effective R&D programs.
Great, thank you. As the chief scientist, how would you say that your position impacts the broader green economy?
Yeah, so in my position as chief scientist, I do a lot of coordinating with external partners, both folks who are actually doing research, but then people who are also, making policy or are doing research, internationally. And so I think what I try to do in my position is to, help make sure that we're having productive conversations and, coordinating with the folks that we need to be coordinated with to really ensure that, the bioenergy technologies that we invest in are, part of a broader solution to tackle our challenges in climate.
Okay, thank you. I just wanted to ask one more question about your work. You've been at the DOE now for almost 7 years, more than 7 years. What are some of your perspectives working in government for so long? And what's it like working through changing administration?
Yeah, that's a great question. I think, so I've had a couple of different roles within the Department of Energy. I started out as a AAAS Science and Technology Policy Fellow in the Office of Science at the Department of Energy, and they're much more focused on kind of basic research. And then I moved from that into a kind of our applied research arm that I talked about earlier. And there I've really been focused on, getting technologies that are sort of ready to be picked up by our market partners. And then, recently I've moved to this chief scientist role. I think across all of those things, there are, because we are a mission-driven agency, I've tried to really help to, align, my perspective of what we should be, investing in and developing as technologies with how our mission is focused. And so here, sort of the second part of your question, working across administrations, I think it is critical that, we keep being able to do the work that we're doing within the Department of Energy to fulfill the mission, but also to make sure that we're responsive to administration's needs and their directions in terms of how, as an executive branch agency, we execute our mission. And so, making sure that we are working appropriately on the administration's priorities is pretty critical, and making sure that our technologies can meet those priorities and help to advance them.
Great, thank you so much for that perspective. I'm curious now about your own experience from the Middlebury campus to your current career. At Midd, you mentioned earlier you majored in biochemistry and you minored in economics. I was wondering if you could tell us the rest of your story.
Sure. So yeah, my foundation at Middlebury really helped me to understand, I think, partly where I wanted to go with my career. And I knew one of the next steps for me after Middlebury was going to be going to graduate school. And so I ended up going to graduate school for organic chemistry and went to Stanford University and got my PhD there in organic chemistry. My biochemistry background really played into that in terms of my choice of lab. I worked there with Professor Chetan Khosla, who does a lot of things both in human health, but also in metabolic engineering of microbes to make valuable products. And the products that we focused on mostly in his lab were all medicinally relevant compounds. But it gave me a really good grounding in how you can utilize biology to make things that are useful for humans. And so during grad school, I think I was always interested in environmental outcomes of these types of technologies. And so as my next step after graduate school, I applied for a AAAS Science and Technology Policy Fellowship. And I knew that I wanted to go work with that fellowship kind of more in the energy space. So moved to DC and started my work at DOE, first at that Office of Science. And there I was really looking at how do you engineer microbes, or I was looking at funding research and how microbes are engineered to make things like biofuels and bioproducts, but really from a fundamental science perspective. So what don't we know about how microbes are engineered and how biology works, which is quite a lot, and trying to help to lay the fundamental underpinnings for that. From there, I realized that, for me, I wanted to work on research that had a real sort of immediate application, because I saw a lot of challenges, that faced the United States, primarily being the one around climate change. And I think the Department of Energy has a really strong mission there. And so I ended up moving to the Bioenergy Technologies Office, like you said, about, I think, 5 or 6 years ago now. And I was a technology manager there for several years, really focused on synthetic biology. So being able to re-engineer microbes, and also on some of our work on lignin, which is a part of plant matter, and how you convert that into something useful, as well as our work on plastics, both redesign of plastics and then deconstruction and utilization of plastics. And that sort of all led me to my current role.
Great, thank you so much. Was there kind of a defining moment that you remember that helped kind of put you on your current path?
Yeah, I think, there are a lot of different areas of science that you can explore. I think that they're all super, super interesting. I think for me, I started out thinking that I might want to work in some sort of health applications, and that really guided my choice of laboratory and graduate school. But, as I got more and more aware of problems in the environment, I think I wanted to sort of shift my focus to that. And I was actually part of the, when I was at Middlebury, really part of some of the more climate-focused groups, like the Sunday Night group, that led to a lot of climate action from various people in Middlebury College. And I think that helped really define for me a need for action in that area, and knowing that I wanted to affect that space, but also thinking that I wanted to have something to do with how the government saw that. I think that getting a graduate degree and then doing a policy fellowship was really helpful for me in pushing me in that direction.
Great. So you would say that an advanced degree played a role in your career trajectory?
Yeah, I mean, I think that there's a lot that can be done, in the sphere of helping achieve great climate outcomes that doesn't require an advanced degree. I think that for me, having technical expertise and a technical grounding in how how science could really help to tackle that challenge has been really, really useful. And I think being able, especially to know enough of the kind of foundational science to be able to translate that into useful either policy or science kind of science direction recommendations has been really helpful for me in my career, and made me feel like I can have a voice that isn't or that has some impact and some grounding in technical expertise. Although, like I said, I've had to move way beyond what I did in graduate school, and you can't be really a technical expert in everything. You can know enough about how science is done to understand the challenges that researchers face, and what sorts of technical barriers are most important to overcome.
Thank you so much. Thank you for sharing your experiences. Given your experiences and what you know now, what advice would you give to current Middlebury students on how best to prepare themselves for entry points into a similar career field?
Yeah, so I think there are a lot of entry points for folks at Middlebury who are interested in this type of career. I mean, I think Middlebury offers you the chance to both explore, deeply explore science, and I feel like I took a lot of advantage of that at Middlebury and really appreciated all the offerings that Middlebury had in that case. But it also, gave me the chance to not dedicate 100% of my coursework to science. And I think that having that kind of larger perspective, and being able to understand how, drawing from multiple disciplines can be really useful in trying to attack a problem from a variety of different angles in a constructive manner has been really critical. And so I think, my advice for Middlebury students would be, follow your passion and where you think you want to go. But at the same time, take advantage of classes that you might think don't play directly into your career field, because I think that that's one advantage that Middlebury offered over a lot of the other folks that I met, say in grad school, who'd done a purely a non-liberal arts-based education. They had a much better science underpinnings, I think, than I might have, but I was able to look at problems, in a different light than they could, and I think that's been really useful in my career.
Thank you. What skill sets would you consider are very important to have for recent graduates?
Yeah, I think that having a strong technical background makes you very, very useful in government. There are a lot of folks in government who are really excellent, either policymakers or administrators or managers. There are less folks who have, really deep science understanding. And I think that's why the AAAS Science and Technology Policy Fellowship that I mentioned before exists, is to help bring folks who have that strong technical background into government roles. So I think that's a really nice skill set to have. Additionally, I think that just being able to talk to a variety of folks who have expertise in different areas and be able to synthesize that information into, really concise, either recommendations or outcomes has been really useful to me in my career, in terms of being able to take folks who are on the technical side and make their messages resonate with people who are making decisions about where to push science and technology funding.
Great. Thank you so much for all of your insights and perspectives. All right, Jay, thank you once again for your valuable time and engagement with us in helping students to prepare for their first career destinations.
Yeah, it was great fun, Nick. Thank you very much for all the thoughtful questions. And yeah, definitely really happy to be here and be able to answer them.
Awesome. So this concludes this episode within the series Exploring Green Careers in the Green Economy. In closing, I want to encourage viewers to tune in to get career perspectives and advice from a number of professionals in a broad variety of organizations in our other episodes in this series. I also want to encourage you to tune into other MIDDVantage series, which can be accessed through the Events and Programs tab on the CCI website. Thank you again for watching.